Hello everyone, welcome to this episode number 9 of this series by Ozzy, which is about game dev. Game dev, when we say game dev and Ozzy, it means the racing car game dev or the racing car game that he is developing. As I said, this is episode number 9, and of course with me there is Ozzy. So hello Ozzy, thank you for being here.
Hello, thanks for having me, and sorry if I'm late. Today I'm in a rush, literally with everything.
Hello Hound Dog, I guess you're here for the points. Hello Dogster. So just to make Hound Dog happy, let's give him the points first. You make me laugh, Hound Dog. There you go. You have your points. So, today, as I said, we're going to talk about the game dev, the racing car game that Ozzy is doing. It's episode number 9. He has some interesting stuff. I went through the slides, so I have an idea of what he's going to talk about. Also, there is one topic that I haven't covered yet since I've been streaming. It hasn't been discussed at all, and even the book doesn't cover it well. So I'm looking forward to hear what he has to say. But as usual, first let's go to the usual stuff where I talk about my things. Let's say that instead of saying the usual ritual. So, guys, please subscribe, like, follow the Phase 101 YouTube so that we can share more the videos because that's how YouTube works. Whether you do a like or not, the more you watch, the more it thinks that it's on demand and the more it will share them. Remember that under each video there is this little thing more that gives you access to links that are related to either the stream, related to the source code of the stream, or related to the actual stream. Source code, when it's published and when it's available, it's on the Mega, so you might need to subscribe to download the source code. And as always, also I have the Phase 101 Facebook page. It is my blog in a way, where I announce whatever I am doing or releasing. Please like, subscribe. It helps us in, let's say, helps us in, or helps you more than me, to know what's going on or what I'm doing. Same thing, we have the What's this? This is a new thing. Introduce contributors to your group. Oh, okay. Um, we have the Phase 101 Facebook group, and like it, we have the Commodore Dev Facebook group. Please subscribe to them. Um, uh, One is about Phase 101, and the other one is about anything related to Commodore, because everything that I do is related to Commodore personally. It's not because I do not like the other machines, but I do not have time for them. So I decided to stick with Commodore since these are the machines that I grew up with. I always had Commodore, so might as well do Commodore, no? Um, if you send me messages on Facebook, I do read them, but I take my time. However, send messages on Discord. Normally, I read them more quickly. Let's say that, and you get an answer from me quicker. Um, I also have a Telegram group. If you do not like Facebook or you do not like um, Discord, you can send me a message there. For those that want to go an extra mile, you can support us. You unlock 106 videos for you to watch, which are related to game dev. And same thing is on coffee. Okay, so they are identical basically. The other things that I have here, I will talk about them later on. Okay, so I need to prepare this, I assume. Yes. And I guess it's time to give my microphone to Ozzy.
So before starting, if I can, I would like just to make a big disclaimer because last week I was not so healthy. I had a bad cold, so sometimes you will hear me cough a lot, and if I disappear in the screen, just wait because I have to blow my nose. So that's it. Yeah, unfortunately, here in Italy, spring is far away. Still, the temperature is not, let's say, like the usual spring. It's cold, and maybe probably have some. This is the reason why I got this bad cold. But whenever I'm happy to be here and just try to chat with you and relax for a moment. So, having said that, I want to go back to my discussion about my artsy game. But uh, um, as you can tell in this series, okay, I'm talking about my game, but this is just uh, the mean in the sense that I just jump to topic to another topic. For example, last time I talked about the action replay, and of course the action replay is not a topic strictly related to my game, but since I found it interesting, I just bring this topic to the screen, and this time is no exception. Because what I did essentially the last 2 weeks, I just received some graphics from my friend Z3K. I think this is the correct pronunciation. I don't know because I usually talk to him in Italian, so I don't know if the pronunciation is good or not. But anyway, he is a very talented artist, and he gave me some of his work just to improve the look and feel of my game. So far, I just implemented some background images, and I just reworked the whole menu system. So all this work ended up in a separate branch, and if if you use Git, you probably know what a branch is. It's just a line of development. So from last time, I just created new branch. I'm just inserting this graphical stuff inside this branch, and just to see which is if it's going in the right direction. It's better. It's not. I don't know. I like his assets a lot. Actually, I think I will bring all of he sent to me. But as I was saying, this resulted in some very boring stuff from the coder point of view, because no no improvements on the game, in the sense that the mechanism, the game is almost the same. I just put his assets into the game, so I have to bleed the letters over his image. So all this stuff is well explained in the Fabio Ciucci's book, so the book with capital B or capital T, as you prefer. This time I tried to just focus on two little things, which for me it's minor optimizations, but I think it's something that it's some uncommon. It's not stuff that can easily found on the internet. Of course, you can find it, but it's not mainstream, I would say. So this is why this time I will just show the game how it looks after the injection of the graphical artist talent of Z3K, and then I will talk about completely different things. So this is my idea for today, and I really hope you will like it.
So shall I show the game?
Yes, you can start from scratch, because it's completely changed from the first screen. You just notice that something is different.
Yeah, and let's see if the sound is there. No sound, we need to make sound. And we start. And oops.
Oh, you are running on 1.3.
Yes.
Good. Haven't tested this platform yet, so I can see if it works.
If it doesn't work on A500, then it's not a game for me.
Okay. It should. It should, but as I said, this new branch is so experimental that I only tested on my A600, and that's it. No checks on other platforms. So there is a high probability, a high chance that you get some problems, some glitches or crashes.
Okay.
So this is the main screen. As you can see, the fonts are the same, but now I just put the fonts on a background.
I need to configure the joystick. Give me a second.
Yeah, you go to. Also, you have to go to car controls.
Oh. Okay. So I can see your car here that you can. I don't know if you can see it. It's a bit too small.
Controls option menu.
Yeah, it's a bit small, the car to see, but I hope you can see it.
Yes, the cursor, I already have the replacement image for the cursor. I didn't have time to inject this asset yet.
Okay.
So car controls.
SP175 target is ECS so far. I don't know. Ozzy, are you going to do AGA or for now just ECS?
The game is tested on also on the 1200, and it works fine, but you won't notice any improvement. So it's an it's not ECS, it's an OCS game for now.
Yeah.
So it just needs a half meg of cheap RAM, and that's it. This is the requirements so far are quite small. There is also another directory on the root of the project, which is artsy AGA, and this is just a test because I wanted initially, if you remember when I started, the initial project was to also release an AGA version with 265 colors. And yes, I'm 56 colors, sorry. And above all, I want to double the resolution. So there is an example inside the book which shows you how to set up a screen in high res and all these colors, and it doesn't work on my initial setup unless you use an emulator. And then I remember you, Faze, told me that there were so many problems using this approach. You just said that maybe it's not the best way to go.
Mhm.
So far it's just OCS game, and that's it. The next step will be AGA, or better, it's an RTG game for high-end Amigas, for example, PyStorm or Vampire. This is in the plan, but not even I didn't even start to think about it, how to do it. Should be quite easy, just to re-implement the calls to the drawing routines, because the game mechanics should be the same. But still, I have nothing to show today about this other platform that were mentioned.
Okay, so let me go into options. Okay.
The option screen, let's say it's very bare. Nothing interesting here. I just put
Uh-huh.
the sound option here because I had all this stuff in a single screen and the screen was very cluttered. I just wanted to so divide, rearrange all the menus in different screen, so that
Mm-hmm.
it's, let's say, the look and feel will be much better from my point of view.
Okay.
So here you just set if you want sound effects, I will put
set them
some
off
music.
because else we will not be able to talk. But yeah.
Yeah, I really hope that this option is working right now. Otherwise, you have to turn your volume of the emulator down.
Yeah. No, I think it works. I tested with the sound though, so
Oh, yes.
yeah.
Good to hear. What's important now is that you do the card setup part.
Okay, car controls, yeah. I played it with the keyboard earlier, so I didn't play it with the joystick, but anyway.
It's the same. This part didn't change.
Uh-huh.
So the third thing that you may notice here is that now we have 8 players. This is
Yeah.
something that, if you remember, this is something that I promised to try and see if the good old Amiga could just do had the computational power, so the power to calculate all the position of all these cars using 1/50th of a second in this situation. So this is the nightmare, I think, of the Amiga. You have 8 car, and you have, for each car you have to check the linked input routine, and then you have to calculate the velocity and the position, the friction. You have to check if it's colliding with the environment and if it's colliding with all the other cars. And if it does, it just must do something to react. So this is a very, let's say, a stress test, just to see if we can do it without using fast RAM or faster processor. And I'm pleased to announce that I'm quite satisfied with the result. Still, I have some raster time to play with. So it's good. I think I will keep this 8-player mode. So you can move the cursor with up down, and every time that you press the fire button, or I don't think, yes, the fire button or the return key on
So shall
your
we switch
keyboard.
them all off?
Yeah, you can also just set all the cars to joy 1, and you will control all the car with the joystick. It's
With
just up to you.
with all, I can control all 8 of them with with the joystick.
Yes, just right. It should work.
Okay.
Of course, in the final version, this is something that you will be prevented to do it because it makes no sense to control all the car with the same
I think I will
input
create a
routine.
mess like this.
Yes,
I'm
yes.
just
Joy 1. So you are controlling 8 cards.
yeah, I
Yes.
want to see this now. Start.
Well, yeah, let's hope it doesn't crash. Okay, start game.
Yeah,
And
yeah.
now I just introduced this in between middle step screen, and this is the track selection. And this is the screen when you return each time that you finish the race. Another thing that I have to mention right now is that I hard coded 1 lap only. So as soon as you cross the finish line, the race is over. And this is because I wanted to test what happens after the race. So in order to keep my tests very short, I just put 1 lap. But if you want more laps, I will tell you how to do it, what to change in the code. You recompile and you have the new executable. If you want to do this later, we can do it.
Okay, so start race.
Yes, start race.
Okay, so I can see 6 cars in alignment perfectly, but 2 are somewhere else. So once I press the joystick, they're going to I'm going to create a mess, I think.
Yeah, you do it. This is exactly what I'm trying to do it right now. I want the game to be a real mess and see if it crashes, if the car gets stuck.
They became a mess and 2 got stuck. Yeah, this is asking for trouble like this. Hold on. Because you set it to all the others have finished.
Yes, the race is already finished for most of the car right now. As soon as you cross the finish line, it starts lap number 1. And I told to the game that in this case the race is over.
Yeah.
But we can change it later if you want. It's not a problem. Right now you have to find
it's finished. There you go. It finished. The race has finished.
Yes. And now what I have, it should
one of the pilots needs to be phase 101, eh?
And there is a funny fact about the names. If you look closely at the names of the pilot and of course of the teams, these are fake names which are taken out from real Formula One
I realized,
teams. Yes, and most of them are, let's say, people from the past or teams from the past. For example, in the past we had in the 80s, we have this team which is called Alfa Romeo, and I rebranded in the Alfa Romeo because it's very funny.
Yeah, instead of Alan Prost, Alan Crost.
Yes, exactly.
JJ Leto, JJ Lento.
Yes, it was yes, it was a pilot from Finland, I think.
Yeah.
And I remember he was always the last to arrive.
Instead of Fittipaldi, Fitticaldi. This is good.
Yes, Pretese is Riccardo Patrese.
Yeah.
It's an Italian, under Italian. And Bagna Cauda is Niki Lauda, actually. Alboreto is Michele Alboreto, and he was hired for Ferrari in '84.
Yeah. I
And
know them
I
all.
remember him because I cheered for him every time. I wanted so badly that he was the winner. So this is
Yeah,
actually
instead of McLaren.
yeah, exactly. Perrault is actually Renault, which are French.
Good one.
But of course, we I could make all this stuff editable. Actually, since I gave you the sources, you can change quite
Yeah.
easily.
Of
But
course, you're going to have a driver named Phase 101. I can tell you that.
yeah, it's definitely possible. Maybe I can just read the configuration from a config file somewhere. I don't know. This is right now. All these names are just hard coded with DC
Yeah.
dot.
Of course.
So this is that my goal actually is to keep name fixes, and I want people to hack the game and change with looking at the strings inside the binary and change it on their own. This is, and on the last column on the right, this is the time that you took in order to cross the finish line, so the entire race time. And this is expressed in frames, not in seconds. This is
Mm-hmm.
just my choice, believe it or not. I know maybe
But it's
it's
easy to make it in seconds, divide by 60, and that's it. No.
yes, but I want maximum precision, and I think the best way to get the the maximum precision is just to put the frame number. But anyway, I can do the conversion. Okay,
Mm-hmm.
it's not difficult. Maybe it's something that I can do in the future.
Actually, you can easily, instead of by 60, divide it by 64. So it doesn't matter if it's 60 or 64. And what remains is the milliseconds.
Exactly.
Yeah. So it's fine.
Yeah, just I have this problem using div on Amiga because of the cycles. But here,
In
performance
this
is not a
case,
big issue.
no, I told you to use 64 so that you don't use div. Use,
Oh, yes,
yeah.
64 is a shift.
Yeah,
Yes.
exactly. That's why I told you that.
But I need the reminder.
You need the reminder.
I need the reminder. And the reminder, come on, we need to
Yeah,
use
the
div.
remainder will be, yeah, but the remainder will be milliseconds. No, so you can you
Mm,
can you can get the remainder. No, when you shift, what remains goes
mm,
into another byte. No. Hello,
we-
Pelicus
Yes,
or Dario.
yes, actually, this is. Come on, why Pellicus is here? He has some serious work to do. He has to build a website. I understand a new web page.
He didn't tell me
I
what he's
don't know.
doing, but yeah. No,
I
no,
I,
no.
kn- I know that
I'm
he
not.
was busy.
I am not like Ozzy. You can stay. He's multitasking. That's why. Anyway, let's continue.
If you go to next race, actually there is another screen, and this is a last minute addition. And this is, well, I don't know how to say in English. It's the
High score.
standing.
Standing.
No, it's the
Yeah. Okay.
standings. Yeah.
Standing.
Every time that you complete a race, I give 10 points to the winner, 8 points to the second, and so
Uh-huh.
on. So every time this point counter is incremented, and there is a sort routine, a bubble sort routine, we just sort the array, and then this, let's say, this table is printed with the points. That's it. Nothing
Mm-hmm.
fancy. And if you have followed my conversation with Gunnar and
No, I haven't.
and Pellicus, we were talking about this. I think the last 3 days at least.
Yeah.
How to make a proper reorder. So it's just a little routine. It's 5 lines in C and 20 in assembler, and we spent 3 days trying to figure out how to do this stuff. So it's very convenient.
Yeah, I saw it. I have other things to do, so I just let you discuss it.
So yeah, the game. This is the game. The status of the game.
Yeah.
Nothing more. If
Let's
you
see.
want, we can recompile and add some laps,
Um,
or I can start the slide.
I
Just-
think it's better if we start the slides and then, if needs be, we can change afterwards. I think that's the best option.
Okay, no problems.
So, and let's take the.
Just one thing that I want to mention: this every image here is not ink binned, because if I ink bin all the image, the final executable bloated too much,
Mhm.
and probably the half meg of RAM was not enough anymore. So I built a new menu system that just takes the file from the disk, it puts in the bit planes, then I print all the letters over the background, and that's it. So this is actually the menu system that I built in
Sure.
the last days. But anyway, I didn't want to talk about this today because it's very boring stuff, nothing interesting. But still, this is something that needs to be done in order to have a completed game. But when I was coding this part, I was very bored. Really, I felt just like I was building a web page, like Pelic
The
was doing right
the
now, and this is not something that I really like to do.
the images, how are they stored on the on the disk? Are they raw? Are they IFF? Are they
Um,
compressed? How are
it,
they?
it's Ozzy format. It's just raw data,
Yeah.
not interleaved, and at the end, I just appended the colors, the color palette.
Okay.
And all these files are inside the root,
So
are inside
so
the root of the disk.
so you didn't compress the image, although it's raw. You didn't compress it.
Yeah, I think in the future this is one area of improvement. I
Yeah.
can try to compress it and decompress it at runtime
Yes.
after loading from the
Yeah.
disk when needed. This
Yeah.
is something that I think I will talk about in the future if I manage to do this, because
Yeah.
I've never. I did live compressing in the past, but it was in C. I used a very
I have an idea
quite
about this, but I will share it off stream. Then maybe you can
okay.
take. Then maybe you can talk about it when you do it.
If you have some nice compression routines, okay. Just to finish this topic, last Sunday I think I just gave a try to the Bartman C extension, and I saw that there is a small snippet of code that unpacks data inside this example, and maybe this is something that I can reuse and bring into my game just to save space. Because if you look to the floppy, there is more than half of the space is already gone.
Yeah, of
I
course.
think
That's why I asked you.
I have two 200 kilobytes left, but no more. This means that
You
if I
need to.
want to add more tracks, I have to provide an additional disk unless I find some sort of compression.
Yeah, you have to compress.
Yeah, this is something that I don't know how to do it right now. I have to ask ChatGPT or someone like you.
Okay. So I'll
Okay,
leave you to
so
it. You can start.
yes, go to slide number 1.
That was number one. This is number one, no?
Yes, maybe it's number 2.
Okay then.
Yes. Yeah. Okay, this is just what I just said, the changelog of the last 2 weeks, new graphic assets by my friend, this new menu system. We now have 8 cards in play, and I did some optimization, and this is what I'm going to talk right now. Optimization, what I did to, okay, there is no huge boost, just small optimization, but maybe I think you could find what I'm going to say interesting. So let's go to the next slide, and I will start with the first one.
Yeah.
And actually, when it comes to optimization, this is something that I really love to do on the Amiga, because of course you have to make your program very lightweight as much as possible in order to hit the full frame rate. So this is my method in order to evaluate the performances. This is a screenshot. It was taken when I implemented the fifth car. And what I did in order to understand if I had enough raster time in order to put all the 8 car, I just changed DFF 180, which is color 0 palette. And this is the result. So I have these bars, these horizontal bars, and these bars just give you a rough idea. It's not so accurate, but you get the idea. The red stripe, it's the time that my program needs in order to compute the next position at the next frame. And the green bar is the time that the program takes in order to calculate the time. So there is a timer on the bottom of the screen if you see. So for each car, there is a timer, and this timer, of course, must be incremented and must be rendered on the screen. The green bar just gives you an idea on how much time this process takes. And this is where what causes all this mess to start on the Discord channel, because I just posted an image like this. I don't remember if this is the exact image, but the idea was, hey guys, I made a new game and this is my timings. The green part is what it takes in order to render on the screen this 0, 1, 5, 1, 2, and the other is 0, 1, 3, 1, 0, and that's it. And I got replies saying that it's taking too much, shouldn't take all this time in order to render this image. So I started researching and trying to find some other ways to do the same job using less cycles. This is essentially what I did last week. So please go to the next slide, and I will start talking about my first optimization. And the first optimization was about the input control routine. So actually, I did more optimization, but this is something that I like to bring here. And this is more or less what happens inside my game loop. So for each car, there is a linked routine, which is part of the car object. So inside the car object, I have this address, and when I run the game, for every frame, for every car, I must read the status of the input routine. This input routine is tied to a device, which is the physical controller. For example, you can set Joy 1 as you did before. You can set Joy 2, Joy 0, or you can set the keyboard. So each combination of the keyboard has a dedicated routine, and each joystick has its dedicated routine. So the joystick port 0 is not the same routine for joystick port 1, which is not the same in joystick port 2. So I have these control routines, and what the main game expect is the register D0 to hold a very specific value. So the game just reads the lowest bits on the right, and according to the values, it just states, okay, you want to accelerate, you want to brake, you want to turn left, or you want to turn down, or you press the fire. The fire essentially is the same as accelerate, but it's used on the menus, because when you navigate the menus, I want a different behavior. If you press up in the menu system, I want the cursor to go up. But if you press fire or return, this is you telling me that you want to select the entry of the screen, and I must take an action. So for example, you want to start the race, you press the button. So you have this, it's different. The meaning of the fire is on the menu system is different from the game. Inside the game, it means you want to accelerate, and inside the menu system, it means you want to select the option that you currently selected. So this is just an introduction on how this works. You have to just remember that you have these bits from bits number 0 to bit number 4. There are 5 bits, and my program is reading these bits. So each routine must put this bit into register D0. And the optimization that I'm trying to show you is only about the keyboard routines, how the keyboard is read by the game. So go to the next slide, and we'll see what I did. And in the meantime, I will just take a sip of water. So this is my old routine. This is the old implementation, and this is actually what I'm used to do while I program on C or with, let's say, modern languages. And this routine just says, if you are pressing the right button, you set the bit 0. If you press the left button, you set bit 1, and so on. And this exact branch is repeated for each command. Let's say in this example, I'm just checking up, down, left, right. But for me, this is not the best way to do it, because I'm using branches. And branches, it's something that, of course, the Motorola can handle branches perfectly, but there are some problems. Here, the first problem is that every time I have to test something in memory, and of course I have to do it because this key D, for example, the key D label, it's just a byte in memory. And there is a level 2 interrupt that is responsible to set this byte, which it's just a byte. It sets the byte to FF if the key is pressed, and when you release the key, it's just reset to 0. This is how it works. And this is handled by my interrupt routine, not here. This is just the check routine to check what is pressed. So after I test the key D byte, and I just want to remind test instruction is just comparing with 0. It's just a more compact instruction that CMP immediate with 0. So I do a branch, and the branch is not something that comes for free, especially with the processor, the old 68,000. It's something that takes time, and the time is dependent if you branch or not. There is some extra cycles in order to be executed if the branch is successful. Above all, I know that some Motorola processors have also this branch prediction capability in order to predict branch. I don't know if it's good or not, if they can predict all this stuff very easily. I think yes, it's not complicated. But again, writing branchless for me, it's something good because I hate to define labels over and over again. So whenever I can, I just go branchless for performance and for readability. This is at least my take. So on the right, I remember I wrote something. This is just there is some on the bottom of the screen. There is the total count because there is this Visual Studio Code extension which tells you exactly how much cycles all this routine takes. And so I tried to rewrite this routine in a clever way. I don't know if I succeeded or not, but I will leave the judgment to you. So go to the next slide and we will see what changed. Yeah, this is just my sketch in order to understand what's the process here. So as I already told you, if I have the key pressed, I have this value ff into the byte. So my idea is to take advantage of an instruction which is inside the Motorola, which is called roll and roar, and they are very similar to the shift instruction. The only exception here is that when you shift, you lose information. When you use roll, the bit which is shifted out, it just re-enter on the opposite direction. So I want to take advantage of this in order to not lose data. So the idea is to perform a rotation to the right of just one shift, and this will just bring the bit in the 0 position up to the left in the word. And this is quite fast because if you shift just one bit, it's not so taxing for the Motorola, unless you are using, of course, accelerated Amigas, which makes no difference, I think, or at least a little bit difference. So what I did is I just copied the least significant bit to the left on the unused part of the register. So I'm just using the high part of the register as memory, and that's it. And I repeat all these steps for each direction. And when I completed the rotation, I just revert the order. And then I just apply a mask in order to get rid of the garbage that could be inside the data register. And in this case, the mask is 1F, hexadecimal 1F. So I tried this approach and I compared the results, and okay, maybe there are better ways to do this. but this is what my mind tried, the best that my mind could handle. And the counter said that I just saved some cycles, not too much, but at least this is something, because I must remember that this routine is repeated for each frame, for each card, using the keyboard. So you have to multiply all these save cycles for each card. And okay, still it's not too much. Doesn't change much, but it's an improvement for me. And it was just to show my approach, how to solve problems, this kind of problems. If you go to the next slide, I remember I put something, some comparison, some performance comparisons. Oh no, this is the implementation. Actually, this is the assembler code. I don't know if you know this program.
No, I was going to ask you.
This is let's say a CPU emulator. Which do you remember the good old Easy 68K?
Yes.
And this is something very similar, but it lives in the browser.
Ah,
And it's very nice.
I need the link to it.
The link, let me check if I can.
I didn't know about this.
There is a link somewhere in the slide.
Okay, then we'll see it. Yeah.
Let me check. Just wait a second. Let me check if I remember I put the link of this sketch. Okay, go to slide number 8, just for a moment.
One. Yeah, okay.
And go in the bottom right of the page. You just copy this.
Yeah.
Block, allow, what is this stuff?
Okay, yeah, because Windows. It tells you that you are. I want to copy it. Yeah. I didn't know about this page. I went back.
Yeah, you can also show us your browser just to see.
It's loading, but it didn't load it actually. So I don't know. It's because it's in your name or something like that. So it's
doesn't
work.
It's not working for
me.
It's not working.
No.
Maybe it's the site is down right now.
So just because that's what I see.
Yes, just try to go to asm-editor.specie.app without the extra stuff, the path of the right, and see what happens.
Yeah, okay, yeah.
Okay, and probably this is just a private repository and you can see it. If you go to the editor,
create, okay.
You can just create. And you the names, whatever.
Interesting. Okay. So the link is this. That's the proper link.
Yeah, this is very convenient for me because it lives in a browser.
Yeah.
And since convenient. I don't use Windows, for me, Easy 68K is not so convenient. So I use this. It's not perfect. I found some, let's say, feature missing, but it works fine. I
for
think
68,000 is fine. No, I mean that's the main the main thing.
For me, it's better, but still, this lives in a browser. So for me, this is a big feature. On the right, you see the memory, and you can inspect the register, the CCR, and you can write code on the left, and you can go step by step.
So
just
it follows
debugging
the EC68K because I'm seeing org 1000. That is exactly like this, like the EC68K.
Yeah, probably the author took some ideas out of
Yeah,
it.
yeah,
And this is just speculation. I think this is a project that it was made by a student of Dark Coder.
oh, really? Okay.
I think yes. My friend told me this. It's unverified, let's say, but I trust him, and probably it's true. And it's just because if you know, Dark Coder is a university professor,
Okay.
and probably he's doing some, let's say,
68,000.
propaganda.
Yeah. Okay. Interesting. Anyway, guys,
Yeah.
take note of the link. It's actually I am going to make a note of it. Going to the leave, and I'm going to go here and make it here so that I have it.
Bookmark it.
Yes.
Okay. I don't know if I can manage with my cough, but we'll try. So this is my algorithm that was initially, say, sketched inside this new web application. I think it's a web application. We can call like this. And so I just simulated the RAM areas where my level 2 interrupt routine stores the data, which are at location 1000. And then I just try to do what I said before. So I just rotate with this roll instruction to the right. It means that one bit is entered to the left of the register, and I repeat all this process for every command. And when I am at the end, I have to do the opposite way. So the final result is that you get the exact sequence of the input that are stored in RAM. And this is, I think, at least in my mind, it must give the same result of the previous routine, but this time no branches, and I'm just using ROR. And ROR, if I remember, it just take 6 cycles plus 2 extra cycles for each shift. So please turn the page so we can see the final result. It's the slide that we saw previously. So yeah, this is the same program, so you can do a step-by-step execution. In this case, if you see, I am at line.
Oh, thank you, Gary Matt, for the subscription. Thank you very much. And welcome to the stream. I didn't see you, Gary. So, yeah.
Can I continue?
Yeah, of course, yes.
Okay, so the instruction RTS is highlighted. It means we are at the end of the routine. And if you notice, in D0, we have the value 1, 5. So we have these 2 bits, or actually 3 bits, that just corresponds to the input that was given at the beginning of the program. So the concept here is just I avoided branches. The code, the final executable, it's a little bit smaller, and I saved some cycles. And again, but there are better ways to do this, probably. But I think this is the fun part for me when I code in assembly. Just try to figure out other ways to get the same result, but with different methods. So your mind is trained constantly over and over and just you are always thinking, how can I do this better? How can I implement this and solve this problem in other ways? So for me, it's fun. Maybe for someone else is frustrating, but yes, that's me actually. So again, please give a look at this very wonderful web application. I don't know if all instructions are implemented here. I found something which was not implemented, but the most popular one, like as you can see, the shift and the moves are there. And so it's very convenient to use. So taking into account if you're looking for an alternative of Easy 60AK. So please, Phase, turn the page
Sure.
so we can finish with my other optimization. Oh yeah, this is the new implementation. It's inside the Visual Studio Code. So what I did in this time, I just sketched the new routine inside the web application. Then I copied pasted the routine here, and then I turn on the Visual Studio Code extension which is 68K counts. I think you discovered this, you suggest this, recommended this to me time ago, and you can see the timings. So the RAR .w, it's 8 cycles, and it's quite short. So okay, it's not the fastest in the Motorola because it's not a 4 cycle instruction, but it's for me it's better than using branches. So because the branch takes more or less the same time, something more, I think, if you have to branch. But yeah, it's also for me it's more understandable what is going on here. So I will keep like that. And just notice the final and immediate instruction is just the application of the mask, just to get rid to the extra bits that are not needed. And you can't see because it was not screenshotted, but I saved, I think, something like 30 cycles or more, depending if the branch is taken or not. So it's not too much, of course, but come on, I did this in minutes. So it's an optimization. Even if it's a little one, you have a compact executable. So I'm pretty happy, and I just wanted to show my method in order what I did to solve this problem. So keep in mind that we have this rotate instruction, which are a nice alternative to the shifting instructions, and even if they are very similar. Okay, go on to the next slide. So this is the performance boost that you can see. No, this is just my second problem, my second optimization. So this is just an image with 8 cards. So as you can see here, the black bar is just a visual representation of how much time I have in order. It's how much time is left if I want to implement something else, and until then I'm not hitting the 50 FPS anymore. So, for example, I had in mind to implement a self-driving car, CPU-driven car, but it's not doable. As you can see, I have the black bar is so thin, so small that it's not possible unless you put my code into fast RAM or whatever. So this is the starting situation. So go to the next slide. I will just talk about this further of optimization. This is a page that it's a photo that I took from a book, my processor book. And there is this very strange instruction, which is ABCD. And this is something that I don't think that RamJam talk about this one.
He didn't.
And this is because it's one of these instructions that is not so popular. So it's not so used, especially in demos. But thanks to this, I saved some time. So what this does is this. You probably already know the add.w instruction. And this instruction just performs an addition. You take the source operand and you add this operand to the destination operand, and the destination operand is increased. So it's just the sum of the two operands. And this is the same. What changes is that this is very useful in case you have to print numbers. For example, do you remember that on the bottom of the screen, I just print numbers, okay? And the problem is that my numbers on memory are represented in this case in a word. So you have this 1, 2, 3, 4. You go to 9, and then you go to A because that's how they are stored in memory in hexadecimal. And you go to F, and when you hit the F, you just reset. You go 1, 0, 1, 1, and so on. And the problem is that you can't print all these, let's say, number in hexadecimal, because what if I tell you that you took FF seconds in order to complete your game? For the average user, it makes no sense because humans, they usually count in decimal form. This is the problem. And if you want to print, for example, if you want to print, let's say 15, you want to draw the fonts to the video in the bit plane, you need 2 bytes. You need a byte representing a 0 and the other presenting, no, I said 15. So
a
a 1 and
one.
a 5.
Yes.
Okay? You can't print F. But in memory, you have F. So this is the problem that I was trying to solve. And previously, what I did, I just divided by 10, take the remainder, and print 5. And they are then divided by 100, take the remainder, and print 1. This is the main concept. But the div operation is taxing. So the Motorola engineers figured out this ABCD. And what it does, it allows you to count using the decimal form. So you don't have to convert it. You just increment by 1 using decimals. So if when you hit 9, you don't get A, you get 1, 0. And these are part of the same byte. The 1 is on the high nibble, and the 0 is in the lower nibble. This is the main concept. And this ABCD allows you to do the addition. There is also the opposite for the subtraction. And also there is this extend flag, which is a flag inside the CCR, and this is part of the count. It means that if you have a carry, for example, you are adding 9 and 1, this flag is generated and it's incremented in the following ABCD instructions. This means that using a series of ABCD, you can count up to X bytes, or X number, as you prefer to see it. And this is exactly what he's saying here. This is the memory-to-memory ABCD operation. You know that you can't, using add, you can't add memory to memory. You have first to store somewhere in some data register. But when you use ABCD, you can go directly into EA and EA. So the source and the destination can be EA, and you must do the pre-decrement version. And this is what it does. And it's very useful on my case. If you want to count in decimal, like humans do, it's perfect. And this is really groundbreaking for me. I really neglected this instruction in the past, but now I think I will use it more. So this is just the description of the ABCD. I think if you have books about the old 68,000, I think this instruction will be reported everywhere. It's just not so widely used. Okay, and on the bottom there is, I don't think it's interesting for us, it's just the binary code, how this is recognized by the processor. So that's it. So turn the page, let's see what I put, because I really don't remember. Okay, this is Easy 68K. I had to use this program now because the web application was not recognizing this ABCD instruction. And this is an example of usage of this ABCD. The first thing that you have to use is you have to reset in some way the extend flag, which is the one used by the ABCD instruction. So you have to put 0 on the 4th byte. In this example, I put 0, 1, 0, 4, but makes no sense. You just have to set 0 into the CCR. Then you have to load the 2 operands in memory that you want to use. And of course, since we are using the pre-decrement version, we have to go to the end, so the higher part of the memory after the text. And then you perform ABCD for each byte. The final result will be that the contents of A will be added to the contents of B, and all of this using the decimal form and not the hexadecimal. I don't know if this is clear or not. I did my best to explain it, but this is exactly, if you are in, for example, if there are some C programmers here, and they probably know the printf function in C, or the sprintf or fprintf, and they put this sf according to the parameters that follows the initial string, so the format of the string. And when they put the D letter, exactly this is what happened. More or less, this is what happens. The print function just converts from hexadecimal and prints the decimal. And this is more or less the same concept. But again, the ABCD instruction is not a conversion instruction. It's just an addition. It's adding operands. It's not converting to anyone. It's up to you to convert later. You have to select the lower part of the byte, the nibble, the lower nibble, and the high nibble, and then do your magic. Usually, I add hexadecimal 30, and I get the ASCII code, or ASCII, I don't know how to say it, in order to reference the correct fonts in memory. So this is exactly what I did. And please turn the page. I think we have the implementation on the game.
Mm-hmm.
Yeah, this is the implementation. So I have my string, the timer text on the top, which is 0001. And this is what I'm going to add, because each frame I count by 1. Then I just fetch the current timer of the car, and I add exactly the 4 bytes, because this is how I count. I'm using 4 bytes. And again, each byte holds two numbers. This means that I can count with 8 digits. Then I go to the end of each text buffer. I clean the CCR, and this is a legit move. This is a very specific instruction, the 68. We have a lot of move instruction. We have move to CCR, like move to EA. You can move to memory or move to register, move to address. You can do move quick, a lot of stuff. Move to CCR is just a ladder, and it's a byte operation. So you just say, hey, I want this byte into the CCR. And I think everybody knows what CCR is. It's just the lower part of the status register. This is where the branch instruction just put the bits in order to make realize the following instruction if the number is equal, if there is a carry, if it's in negative, and so on. So a lot of stuff. And so then I just do my decimal addition. I did just 3 times because I'm not using the 4th byte. I just put there for alignment. And then the result is moved into the 0. And that's it. So I think it's quite straightforward, and all this code is just replacing a long series of divisions. And this is quite useful for me, because the divisions in the stock 68,000, I think they take about 150 cycles. I don't remember the number exactly. And the ABCD, I think it's just, I don't know, 8 cycles, 6 cycles. I don't remember. Of course, this version has to fetch the contents from RAM. But again, we are deleting at least 3 or 4 divs. So you have a little, it's quite big performance boost in my case. So please go on, turn the page. We should see the comparison. Notice the black part of the screen is much more right now. If you compare the 2 images, you can see that the green stripes are a little bit, let's say, thinner. So this is just another way I did to optimize. And again, I don't know if I will keep all this code, because at the end of the day, having this timer, which is repeated for each car, doesn't make much sense to me.
Can,
It was implemented at the beginning because I just want to see how much time do I need to perform the full lap, but I don't know if it's the right call here.
can I ask you one thing? How many
Yeah.
times you are updating the timer at the bottom? I mean, is it per frame? Is it every frame you're updating it? Is it, I don't know.
Every frame, I cycle through each car in play. For each car, I take the timer, because one timer is tied to a car.
Yeah.
Because of course, when you finish the race, you were quick, so you have the timer stops before, and JJ Lento, for example, stops later. So I need different areas of memory in order to store different
the reason why I'm asking you is, let's say the cars, you're doing the first lap, right?
Yes.
And the cars all start at 0. So all 8 of them start at 0. And you're doing the first lap. Okay? All the seconds, all the frames, sorry, will be the same for all of them. So
yes.
So basically, you do not need to calculate, let's say that, for all 8. You just take one and repeat it. Then, when they cross the finish line, okay, you take a note of it.
Okay.
Yeah.
And you can just figure out the differences between times.
Yes, that's what I...
Yes.
And those that has finished, you can even skip because there's nothing else to update. I'm just, you know.
The problem is that I still have to count for each car, because I want to compare the fastest lap. This is my problem. So I want, every time that you cross the finish line, your counter gets reset and they start counting again, because I want to know each lap which was your time. This is why I'm just counting right now. Does it make sense to you? Of course.
No. I understand. I understand you. It's just that, do you really need to have 8 at the same time? That's my...
The rendering, of course, no. I could avoid the rendering, which is taxing, of course.
Yeah.
Do you have to count for each one? I will say it depends. How do you want
if
the
you
game?
if you turn this into seconds, okay, and milliseconds, then definitely you don't need to update the screen every frame. Definitely. And you can only update the screen every second.
You are saying to me that there is no need to update each frame. I can just update.
No, you don't. You don't, because, between 1 second and another, there are 60 frames. So you will be updating that every 60 frames.
But what do you mean with updating? Just using ABCD or the rendering? Because
they
are
count,
two different operations.
Where you have the rendering of the numbers, basically, you do not need to update it.
The rendering, it's not a problem, because I will get rid of the rendering. It's just there for debug purposes.
Now, Pericos is saying both. Eventually, it will be both if you stop using frames, actually. If you make it seconds, then...
I don't want it. I want to make frames, because it's the atomic part of the time, and it's the way I can be much more accurate.
Okay, I think it's something that we need to take off topic. I'm pretty sure Dario, I think, is following what I'm saying, Dario.
Yeah, he knows the problem. I explained to him.
Yeah.
Still, my conclusion is that yes, I don't need to render all this number here,
Uh-huh.
but still I need different location where to store the timer for each car,
Yeah,
because
you
the
have to store
addition
it.
I need to add, because I want to know exactly when the
Yes.
Ferrari starts the lap and when it ends the lap.
Yes,
So this is my goal.
you still have to store it somewhere, but the update to the screen, it doesn't need to be every frame. And also
I think the
the
final release
calculation
won't
doesn't need to be
update
every
at all.
frame.
The update, when you say update, it means the rendering. They move into the bit plane.
It's both what I'm saying, like what Pelicos is saying, but I think we have to take it offline so
No,
that we understand.
I can't get rid of the ABCD, or at least the addition. I need the addition.
No, you still have to do that. You still have to do that, but I don't think you need to do it every frame. Because if you change 2 seconds, then why do it every frame?
Come on, if I do the addition every 2 frame, I get the timer will just report the number of 2 seconds.
Yes.
So you at the when the the race ends, it will just say you took X 2 seconds.
Yeah,
Complete
and you
the
have
race.
and then the remainder of what you have stored
Oh,
is
if you need the remainder, you have to count every frame.
no, you don't need to calculate it every frame. You need to calculate it at certain intervals, because frames is every frame and seconds is different.
Yeah, but I'm not thinking in terms of seconds. I'm
I know.
thinking in terms of frames.
Mhm.
For me, the seconds concept is not inside the game. This is something that I tried to do in the past with the CA, because there is a timer inside the CA. But at least I think,
With the timers, you have to be a bit careful, but yeah.
yeah, this is some dark territory for me. This is something that I really wanted to avoid. For me, it's just every time that there is a vertical blank, for me it's a frame, and each time I just increment the timer
Yeah,
for
I
each
know, I
car.
know what you're doing. Yes, I use your same system, but when in this type of game, it's consuming. If I do my simple games that I do on the streams, then that's fine. But for such a game, it's not the right method to do
I'm
that.
open to suggestions. A possible area of optimization would be just not to render the screen, so the numbers each frame, and I totally agree. And in fact, I before I said all this lower part of the screen will be reworked. I don't need to have all this information. I will
Okay,
just
Pelicos.
stick with the lap number and the best lap, probably.
Sure.
So yeah,
Anyway,
so
I guess we are. This is the last slide. There isn't any more, and we arrived at the end of the slides of Ozzy. I hope.
my call went away. Incredible.
You see, that's why I told you to continue. I knew it will go away. I had to bother you with the frames so that you ignore it.
Yeah,
Guys, I hope you find this episode interesting. Also, I'd like to thank Ozzy for making the effort to be on this stream and sharing his info related to his game dev. I always learn from his stream because I do have my ideas, but I do not have, me personally, do not have any other devs to talk to. Let's say that. And hearing him, it's a. I mean, when it comes to game dev, um, it's always interesting to hear him talking. Um, so I always ask him, do you have something prepared for Tuesday? And when he tells me no, I know that I have to wait another week to hear his
Yeah,
advances related to the game.
I'm a last
Um,
minute guy. Sorry.
so yes, it's something that I look forward in a way because there are no other except Hoffman, which I also learn a lot from him. There isn't anyone else that streams Amiga stuff, and when I say Amiga, I mean dev stuff. So yeah, I look forward for such episodes. Besides that, I also don't know a lot of game developers on in the Amiga scene. They all seem to be, let's say, reserved. Let's use that word. I mean, I don't see them, do not meet them in this in other channels. Anyway, so guys, thank you very much. Thanks once again, Ozzy, and let's start this charade. Thank you, guys. Bye bye.